Hi all. So today let's see what are the different types of transformation operators which are available in Rxjs. One of the most commonly used operator is the map operator, which basically takes in values from a source observable and you can apply a project function or basically you can pass the values through a function and emit those resulting values. So this is how it works. So this is a stream of data coming from an observable. So here we have 1, 2 and 3. These values we can pass through basically a function which we can provide within the map operator. So you can see that here basically they are just multiplying each value by 10. So the emitted value will be basically the result of the execution of this function. So each value will be multiplied by 10 and the resultant value will be emitted. So now let's see the same within our playground. So here again I have created a function demo map. So this demo map will be bound to the HTML so that we can see the result from that observable, and also we are logging the result values from the stream so that you can see the flow of the data. So here initially I am creating a stream containing 3 values using the from operator, so 10, 20 and 30, and I am going to pass this observable using the pipe, and the data from the observable will be passed through the map operator where I will be multiplying each of this value by 100. So now let's see this in action. So I am selecting the map operator. So in the HTML you can see that only the last value which was emitted will be shown because we are binding it to the same variable. But in the console you will be able to see that each of the value which is emitted, that is getting multiplied by 100. So the map is a very useful operator in which you can do many kinds of operations. So another commonly used operation is like in case you need to pluck or get a particular field from an object. So in this scenario, I have an array of objects which have the properties name and age. So my main function is that I need to get the age alone returned as a output from this observable. So what I am doing is the same thing. The source I am using the pipe operator, and within the pipe I am passing the map operator, and here what I am doing is I am just returning the age property alone from that object. So when we run this, you can see that the age alone is emitted from the observable and the last age will be displayed here. So this way we will be able to isolate any particular property and return it as the output value from the observable. So there are 4 commonly used operators which are related to the map. So these are the concatMap, the mergeMap, switchMap and the exhaustMap. So let's go through each of them. So the concatMap, basically what it does is it takes 2 observable streams as input and basically flattens it. So flattens it basically means it will be emitted, the output will be emitted as a single stream with data from both the input observables. So in the concatMap, what it does is it takes the initial value, there's a first value from the first observable, and then here we are multiplying that by 10. So each of these 10, there are 3 values from the second input observable. So we will be multiplying each of this value with the first emitted value. So we have 1 into 10, 10, 10, 10. So these 3 values are emitted, and at that time the second value came from the first observable, that is 3. So what happens is that again this 10 will be multiplied by 3 and these 3 will be emitted. But you can see that while this particular operation was going on, actually the third value was emitted from the first observable. But what the concatMap does is that even though it got emitted during the second operation, that is the 30 was emitted, it waited till that particular operation was completed. So it basically means that the values will be emitted in a sequential manner. That is, even though a new value is emitted from the input observable, in between that, it will be queued and it will be emitted only after the current execution is completed. So here, when the 5 is emitted, it waits till the value 3 operations are completed and then it emits the values related to 5. So now let's see this in action. So within the code, what I have done is basically taking values from the click event. So when I click on the document, a particular click event will be emitted, and within the concatMap, I will be starting a timer which emits values at 1 second delay, and we are taking the first 5 values. So basically it will emit from 0 to 4. So now when we go to our playground and click on the concatMap, you can see that initially the values 0 to 4 are emitted. So now I am going to click one time. Again the stream started. Now I click one more time. You can see that it is not started now, but after the second iteration is completed, then only it will start emitting from the third click. So we can add a tap operator just to see when the click gets started. So I am adding the tap operator. So now when we run our application, you can see that I clicked. Now the values are emitted. Here again I clicked, but even then the previous values are still getting emitted. So it emits the values in a sequential order. So for each click, it will be emitted in a sequential manner, that once the values of the previous stream is completed, then only the next value will be emitted. So now let's see the mergeMap operator. So the mergeMap operator is quite similar to concatMap, but the way in which it emits the values, it's different. So here if you see, you can see that initially the value 1 is emitted and all the related outputs are emitted. Then the value 3 is emitted from the first stream. Then it multiplies and emits that. But in between, when the 5 comes, it immediately emits that value which is processed by this function. So it does not wait till the current input is completed, but it merges both the outputs. So basically, you can see that 30, 30, and when the 5 comes, immediately the first value, that's 50, is emitted. Then the next 30 is emitted, and so on. It continues. So now let's see the same. So again, I will add a tap operator just to demo that. So let's go to our playground. So I am clicking the merge map. So initially the first stream is getting emitted. So I will wait till that is completed. Now I am clicking. So it acts normally. But again I am going to click. So now you can see that immediately the next value is also getting emitted. So it basically mixes or merges both the outputs. So it came like 0, 1, 2, then 3 came, but in between I clicked. So immediately, instead of waiting for the previous thing to complete, it started emitting the next one. So again, suppose I double click on this, you can see that the values are getting emitted twice, which is getting merged. But in case of a concatMap, it will be waiting so that one stream is completed, then only the next value will be emitted. So next we have the switchMap. Basically it is similar to the previous two operators. It accepts two input observables and it will be flattening the inputs and emitting it as a single stream. So the difference between the switchMap and other operators is that when a new value is emitted from the initial observable, the previous stream gets cancelled. So here initially we have the value 1. So all the values got emitted. Next 3 came after the output was emitted. So there is no impact. So it starts emitting. But at that time the value 5 came. So the value related to 3 had not completed emitting. But what it does is that immediately it cancels the previous emission. So here you can see that the third value is not emitted. The stream is cancelled and immediately the next set of values are emitted. So this is the difference between the switchMap and the concat and mergeMap. Concat and mergeMap always emits the values, but the switchMap basically cancels the previous emitted values and it will start a new iteration. So again, let's see the same within our application. So let's go to the playground and we have the switchMap. So initially I clicked, so the values are getting emitted. It's fine. I am not going to click. So all the values got emitted. Now I am starting a second iteration. So it's in progress. Now I clicked. So you can see that the second iteration was cut short basically. The values 2, 3 and 4 were not emitted because a new value was emitted from the click pipeline. You can see that the switchMap operator, it cancelled the previous iteration and it started a new iteration. So the exhaustMap is exactly opposite to what is the switchMap is. So here what happens is that again it accepts 2 input observables, but you can see that initially when the value 1 is emitted, it emits all the 3 values, and the next value is 3. Again it emits all the 3 values, but the value 5 which was emitted in between the iteration for the value 3. Okay, so before the value 3 output values were emitted, the value 5 was emitted from the first. But what happens is that exhaustMap just ignores this third value. So it is not like the switchMap. SwitchMap basically cancels the previous iteration, but the exhaustMap basically cancels the current iteration. So the newly emitted value that is getting cancelled and the values related to that input will never be emitted. So this is the way in which exhaustMap works. So now let's see the same in playground so that you will get a better idea. So here again, I am waiting for the click and I am emitting an interval taking the first 5 values. So I go to the exhaustMap, I click on it. So initially I am waiting for all the 5 values to get emitted. That's fine. Now I am clicking on the document, the second started. Now I clicked one more time. Again I clicked. But you can see that these 2 clicks which I did during the emission of this second iteration, those were ignored. But now when I click, that emission will be taken. So this is the way in which exhaustMap works, which is totally different or exactly opposite to what the switchMap does. SwitchMap cancels the previous iteration, but exhaustMap cancels the current iteration. So these 4 map operators, these are very much useful and most commonly used in the real world applications. So the next set of operators are the buffer related operators. So buffer basically means that it buffers the values from a particular observable and it emits based on some conditions or some actions. So here we have the basic buffer operator. So what it does is that you can provide a close notifier. Basically, when that particular event happens, the values from this stream will be emitted as an array. So here in this example, we have a input stream which emits the alphabets A, B, C, D till I. Now we have a second stream of events which basically acts as a trigger for emitting these values from the first stream. So when this particular event happens, you can see that all the values which had been collected from the input observable, it will be emitted as an array. So when the first event happened, you can see that A, B, C were emitted. So those values will be emitted as a array. And when the second event happened, D, E, and F had got emitted. So those will be emitted. So similarly, it keeps on continuing. So let's see this in our playground. So in our sample, what I am doing is I am taking the trigger as the click event from the document, and basically the input source will be an interval which emits new values every second. So when a particular document click happens, the values which were emitted from this interval, it will be emitted as an array. So you go to the playground, you can see that now the timer has actually started, but no values are emitted. So when I click on the document, immediately what all values which had been stored, it is emitted as an array. Now when I click a second time, all the values which had been emitted in that particular time before the click, it got emitted. Now there are different variants to the buffer. So one is the buffer count, where you can specify a count. So basically after every 3 emissions, so here in this example, A, B, C are emitted, so 3 values are emitted. At that time, those values will be emitted as a array. Then here we have a second optional parameter. This is the interval in which the values needs to be emitted. So whenever a new every other value is emitted, these 3 values will be emitted as a list. So initially we have ABC emitted, then after that D came, E came. So the value 2 is satisfied in the second parameter. Now what it does is it emits C, D, and E. Then again it jumps to F and G. When G is emitted, it emits E, F, and G. So this way, based on the count, it will be emitting the values. So here in this sample, I am using the size as 3 and I am not giving any interval. So when I don't give an interval, it will be by default the count itself. So let's go to the playground and clicking on the buffer count. So here you can see that without any user action, whenever 3 values are emitted, it automatically creates an output as a list and is emitted in the output observable. So similarly, we have the buffer time, so which is based on a time interval. So you can specify a time interval, and on each of this time interval, new value will be emitted as an array. So here again, I am giving 2 seconds as a time interval to the buffer time. So every 2 seconds, the accumulated values will be emitted. So here you can see that initially 0 is emitted, then 1, 2, 3, 4, 5. So whatever values get accumulated during that time period, it gets emitted. Similarly, we have the buffer toggle. So here you can basically give a starting condition and a stopping condition. Like when the starting trigger happens, it starts collecting the values, and when the closing condition happens, it emits those collected values. So here we have the opening trigger. At that time, it starts collecting these values A and B. And when the closing happens, only this A and B are available, and immediately the collected values are emitted. Now it doesn't collect all this until the new opening comes. So when the opening comes, F is the value that is emitted after the opening, and immediately the closing happens. So only F will be emitted. All these intermediate values will be discarded. So in our example, here what I am doing is basically I am giving the click as the opening, and once I click, it will collect all the values which are emitted within the time interval of 500 millisecond. from this particular source. So let's see that in action. We have the buffer toggle. So now the gate has not been opened. When I click on the document, it is opened. But since the time period is very low, it didn't collect any values. So now you can see that it collected the value 16. Now again it didn't come. It didn't come. So it keeps on varying. So now let's increase this timer to 5 seconds so that all these values which are emitted within this 5-second period will be emitted. So I have clicked on the document. Now it started collecting and 5 seconds is completed. It emitted the value. So again I am clicking on the document. So it collected the values and it emitted as a list. So similarly, we have the bufferWhen. BufferWhen is quite similar to buffer, but you can provide a factory function within this as a parameter. And based on the logic of that factory function, the collection and the emission happens. So let's see this in our example. So here what I am doing is the factory function basically needs an opening. So I am provide the document.click as an opening, and once this particular execution happens, it starts emitting from the interval. So let's go to the playground and clicking on the bufferWhen. So immediately the initial value, that is empty, is emitted. Now when I click, again it emits all the collected values. Similarly, whatever collected values are present, it immediately emits on click event. Now we have another set of operators called window operators. This is quite similar to what we previously saw in the buffer operator. The only difference between the window and the buffer operator is that whenever a particular event, that is the closing event, happens, in the buffer, usually we get a list of values, that is an array of values will be emitted. But in the case of window, an observable stream or an inner observable will be emitted, which will contain the values which were stored. So here you can see that when the particular window event happens or the window closes, the values which were collected till now, that is A, B, C, it is emitted as a input stream rather than a list which is done in the buffer. So other than that, the functionality is quite similar. We have the window count, window time, which is based on time. Window count is based on count. Window toggle, where we can toggle the opening and closing of the window. This is similar to the buffer toggle. And we have the windowWhen, which is accepting a factory function, and based on that function, it will be emitting the value. So let's see this in action. So in our playground, initially we have the demo window, which will be taking the window operator, and we have the window closing event, that is the click event, and the interval, that is the input source from which we will be taking the values. We are passing the trigger, that is the click, to the window operator, and after that what we are doing is we will be receiving a input stream, that's an observable stream. So from that observable stream, I am basically taking the first two values, because this stream will keep on continuing until it is closed. So it will not be possible for a proper demo. So I am taking the initial two values only, and then I am calling the merge all operator, so that we will be flattening the streams. Since there can be multiple streams, all these will be flattened and we will be seeing a single stream of values. So let's go to the window. Initially when I click, the values 0 and 1 are emitted. This is because when I clicked on the document, it triggered a window. Now when I click again, you can see that the values 10 and 11 are emitted, which were the stored values at that particular time. Now when I click again, it will be 19 and 20. So similarly, we have the window count. So here in the window count, I have given the value as 3. So every third value, it will start emitting a stream, and from that stream, we will be taking the first two values. So let's go to the window count. So initially it emitted 0, 1. Then after three values, that is 1, 2, 3, it skipped. Then started 3, 4. Then 6, 7. Then 9, 10. Similarly, it goes on. Now we have the window time. So here the time I have given us 3 seconds. So every 3 seconds, it will emit two values. So 6, 7, 9, 10. So in case we change the window time, it will change accordingly. So here I am changing the time as 5. So after 5 seconds, the two values are emitted, and after 5 seconds again, two values will be emitted. Then we have the window toggle, again where we can provide the opening, which is a click event, and the closing, that is the window will close after 3 seconds. So let's see that. So when I click, the window is open. After 3 seconds, window is closed. So next, when I click again, the window is opened, and after 3 emissions, it is closed. Now we have the windowWhen, where we can provide the factory function. So I have given the click event itself as opening, and from the emitted stream, we'll be taking two values and flattening it. So when I clicked initially, the window opened, I took two values. When I clicked again, the window opened and I took two values. So these are the window operators, which are quite similar to the buffer operator. Next, let us take a look at the expand operator. So the expand operator is quite similar to the mergeMap operator, but the only thing is that the function which we pass to the expand operator, it will be applied both to the input stream as well as the output stream which is created. So here we have an input stream containing the value 1, and we are passing that stream through this function where we are multiplying the values till the value, that is output, reaches 8 when we close the output. So till then we will be multiplying it by 2. So initially we have the value 1 which is emitted, then that is multiplied by 2, then that output again is multiplied by 2, so still it is not equal to 8. So again that will be multiplied by 2, and now the value is 8. At that time the stream closes. So this is basically a kind of recursion. So now let's see an example within our playground. So here what I'm doing is, initially we have the click event stream, and each click I am converting it into a number, so that in order to get an input value as the initial value. So once I get this 1 as the value, I am passing it through the expand operator where I am multiplying it with 2, and the resultant stream I am terminating by taking the first 10 values. So let's go to the playground. I am going to the expand tab. So once I click, immediately the stream starts, and it keeps on growing by 2, like it grows exponentially by 2 till the first 10 values are emitted. It's basically 2 raised to 9 will be present here. So similarly, in case I give a different value, say I take the first 15, you can see that it keeps on growing exponentially till those condition is met. So next we have the groupBy operator. It is a quite useful operator which can be used for grouping together values based on some criteria. So here I have an observable stream which basically emits these values. So it is a list of objects which have the properties ID and name. So in case I need to group this together based on the ID, what I can do is I can pass this stream through the groupBy, where I can mention that I need to group by based on the ID. So the resultant stream will be given here, and using a merge map, what we can do is we can iterate through this resultant streams, and we can use the reduce operator to create an accumulated value. So here, let's see this in action. When I click on the group by, you can see that two values are emitted. And if you go inside, you can see that actually these values are grouped based on the ID, which is what we had given within our group by operator. That is, we need to group by the ID. So since we have the IDs one common here, the test and test1 are grouped together, and 2, which has the test2 and test3, they will be grouped together. So in case I had given the name as the grouping, since there is nothing common, 4 values will be emitted. So here, once you click, you can see that 4 separate values are emitted, and each is grouped based on the name rather than the ID. So similarly, we have one more operator, that is a pairwise operator. It pairs the consecutive emissions. That is basically, this is an input stream which emits A, B, C till E. So pairwise, what it does is it pairs these together, that is A and B together, and emits a value. B and C together and emits a value. C and D, D and D till it closes. So it basically creates pairs. So here in our example, I am basically going to pair together each value that is emitted from the interval. So every second a value will be emitted, and it basically emits a list of pairs. So I am going to click on that. So 0, 1, 1, 2, 2, 3, it keeps on going. Every second when a new value is emitted, it will be pairing it together with the previous value. So next we have a set of operators called the scan operators. The scan operator is quite similar to the reduce operator, which basically acts as an accumulator, and the reduce operator only emits the last accumulated value, but the scan, what it does is it emits all the current accumulated state as well after each new update. So for example, here we have an input stream which consists of 1, 3 and 5. So we are passing that to the scan operator, and we are basically adding that, and we can provide a seed, that is the initial state value. So here we have provided the initial state as 0. So in case you have provided it as 5, then the initial value will be 6. So here now what it does is initially it will add 0 plus 1 to limit that value. Then it will add the next value, that is 3, to the accumulated value, that is 1. 3 plus 1, 4. Now that is emitted. So this is the accumulated value, and the next value is 5, which is emitted. 5 plus 4, 9. That will be the output value emitted from the scan operator. So let's see this in action. So we have a demo scan, and on each click I will be emitting a new value of 1, and basically we will be passing that value to the scan operator. So it will emit a stream which is incremented by 1 for each of the output value. So let's go here. So here let's go to the scan operator. So here you can see that when I click on the document, the initial value emitted is 1. When I click again, the value is getting accumulated and it is incremented by 1. So similarly, we have two more operators, that is the mergeScan and the switchScan operator. The mergeScan basically it merges two input observables to an output observable. So this is quite similar to our mergeMap. The only thing is that instead of mapping, it will be doing a scanning and it will be accumulating the values instead of merging it simply. Similarly, we have the switchScan. SwitchScan is similar to the switchMap, where the previous emitted values will be cancelled in case a new emission happens. So let's see this in action in the playground. So we have the merge scan. So on each click, I am generating a new value of 1, and that value I am adding to the accumulated value and multiplying it by 300 millisecond. So basically I will be creating a new stream which has the interval based on the accumulated value and the new value. And from there I will be taking the initial 5 values so that the console won't be clogged. So let's see this in action. So I am clicking the merge scan. You can see that the first 5 values got emitted. Now when I click again, based on that value it starts emitting, and I clicked one more time, so it basically merged both the outputs. The difference between the merge scan and switch scan is that in the case of switch scan, when I click and a new value is emitted, it basically cancelled the previous emission. So this is quite similar to the switch map which we earlier saw. So hope you are able to get a good idea about the various transformation operators which are available in Rxjs. We will be continuing exploring the different Rxjs operators in upcoming videos. See you soon. Thank you.